Hi there, welcome back. Today we've got something a little different, and you'll see in a minute why I decided to do this video. This is a DAT, a digital audio tape player from Pioneer. It's the D-07, and it's actually on. And believe it or not, it's actually playing. The problem is, you don't see any proof of that on the front panel. It is completely dead. And in fact, I can get one little light to come on if I choose the wide mode over there. Now, the problem with this thing is it's playing perfectly. There's nothing wrong with the audio reproduction, just that the entire display, which is a fluorescent display, is completely dead over here. Now, I found the schematic for this, by the way, which is a great help, always is. I've done some searching on the web, and I've discovered that these Pioneer DATs had a reputation for a burnt-out display. And what I'd like to do is to determine whether that's the case or if it's something a little less ominous. But the other reason I want to show you this is because I want to show you the quality of build of this piece of equipment. It's absolutely unbelievable. The quality of the build on this thing is really, really top-notch. Starting with the copper cabinet. The inside of this thing is copper. None of that steel for you. And then the way this thing's laid out, it's really, really well done. I see these occasionally, but not often enough. So when I do, it's always a pleasure to work on them. You see the caps and some of the actual ICs have got a copper strip on them. That's to reduce noise. You have to remember this is a digital audio tape, so there's digital and analog going on in here. So they went to that length. And everything is so clean. It is so different from what we're used to seeing today that I think it's worth paying a little bit of more attention to it. Now, these things weren't cheap. Hell, they still aren't cheap, but you're certainly getting what you paid for. And that's more than you can say for a lot of the modern stuff. Feast your eyes. Now, the problem I face is that the display is on that front board over there, and to get to it, I have to dismantle this whole transport, remove it, and do some checking. But the one thing I've realized from all the reading I've done, and it's been quite extensive, is that sometimes it's got nothing to do with the display at all, and it has to do with the supply. So following the first rule of troubleshooting, check the voltages. That's exactly what I'm going to do. But first of all, I want to have a look at the schematic and see what voltages I should be looking for. Now, the one thing to look for with these displays is that it usually works with the sort of thing you'd find in a tube, a valve. That's basically what you have here. You have a grid, an anode, it has a filament, and they've kindly provided a schematic with the pin layouts over here, which gives us an idea of what to look for. The legend here says F for filament, G for grid, P for anode. That'll be plate, I suppose. And we find that the terminals, it's not that complex. You've got the F1, these are joint, and so the two end ones, F1 and F2, will be the filament, and the filament will usually be an AC voltage. I'm not sure what voltage they use over here, but we should be able to determine that. And then all the other elements are controlled by you would have the grid connections, 10G, 9G, so you've got all the numbers over here, 9G, 8G, 7G. That will be controlled by those points over there, the grids. That's the number of the pin, 36, 37, 38, and so on. There's a lot of them not connected. Then there's also all the anodes, which I presume will be where voltage is provided. I presume this will be fairly high voltage. Now, fairly high voltage, I think with these things is about 30 volts, minus 30 volts, if I'm not mistaken. So other than the filaments, which will be AC voltage, those are not connected. Those are all anodes for the respective letters over here. You've got all the little letters on here, S, R, P, N, M, K, J, H, and so on. They're all marked as anodes. Those there are all empty or not connected, and then you've got the grids. Now, I want to find where the power comes into this particular board. Now, I've got a full page here which shows us that board, and it's not that easy to see, but if I zoom in, basically the display unit is this thing you're seeing over here, and it has a connection to chassis. There's a small connector here to one of the other boards which has to do with the switching unit and the LED unit. We're not interested in that, except that'll probably take voltage as well. This one is the input select board, which will just be a switch. Yep, that's what it is. And then we've got two connectors that connect to the main board, and I think this is where it gets interesting. Let's have a closer look. We've got AC over there, ground, AC2 and AC1. Those, I presume, will be the filament. If I follow that line there, yep, that goes to F. And if I follow the other one, AC1, that goes down here, all the way down here, and it goes to the other F. Yep. So AC1 and AC2 are the heaters. If there's no AC voltage on there, that display wouldn't work either. Then there's 5 volts. Where does that go to? VD 5 volts. That goes to, this will be the remote infrared receiving diode. And it also goes to the switching board, and it also comes down here, and it actually does go to one of these, but I don't think that's a supply at all. I'm thinking, and what I've seen so far is that the switching gets done on the main board, so I think only the signals come into here. Now I need to find out where that switching will be. If I go back to the top thing there, let's see, these are all pin 16, 17, 18. So from pin 5, you've got anodes or plates, 5 to 20. Where is that? Pin 5. So it's T0, T1, T2, and so on up to 16. So that'll go to the main board. And then the S's will be the grids. So I need to see where that goes on the main board. Let me find it on the main board. That's the problem with this. You've got to jump around quite a bit. Okay, I found where these connectors come into the main board. And if I go up here, I've got VAC2 and VAC1, and that's directed off somewhere where it's coming in. It's not here. There's ground. And then I see something here which is interesting. This point here, VPP, minus 31. I think that indicates minus 31 volts. This would be the main contributor to the display being completely off. So I need to find out where this VPP comes from, because I've got a feeling we've either got one or two things. We've got a supply problem, or we've got the actual display has just run its course, because these displays do wear out, and it gets to a point where whatever you do, you just can't get them back to life. And that is a real bummer, because this thing will be totally useless without it. Not that it doesn't work, but it's kind of pointless, and I don't want to give up on it just yet. So I'm going to look for this minus 31 volts. And I've got to tell you, I saw a video by a fellow YouTuber called 12 Volt Vids, where he was trying to repair one of these displays, and he had the same problem. This minus 31 volts was not there, and it was actually minus 31 volts he was looking for, which is quite funny. I guess these are pretty standard voltages for these displays. It was a totally different display, but it was also minus 31 volts. So I'm sort of following his way of thinking, and his way of thinking was what gave me the idea that perhaps the display is still alive, and that this thing can be salvaged, because it really does deserve to be. Now, minus 31 volts, I don't want to go look for it I don't have to look for it anymore on the front board. I can look for it on the main board, which is where we're in now. But I want to see where this comes in, because if I can isolate this to the power supply board, that one is definitely a lot easier to get to than the main board. Believe me, this is a mess over here. I don't want to undo all that. So let me go find this, see where this thing comes into the main board. Found it. Here it is. It's connected 10 on that main board, and it's VPP, and it's right next to the two ACs coming in. So this is going to the power board unit jumper 10. Okay. This is connected 10 over here. We've got 5 volts, ground, 12. This is the power supply, all the various power supply points coming in. So we've got 5 volts, ground, 12 volts, ground, P, 9 volts, P off, AC1, AC2, and VPP. So let's go and find this unit, power unit, jumper 10. And here's the power supply. This is the power supply board, or power supply unit as they call it. And there's where it goes to connector 10. So it's this guy over here. So we had 5 volts ground. Yeah, this is the one. 5 volts ground, 12 volts, 9 volts, P off, AC, AC, and VPP. Okay, where does that come from? So VPP, which has to be, according to this, minus 31 volts, comes from this transistor. So this is this is just a regulator. Yeah, this transistor is acting as a regulator. You've got a diode over here. I can't see what voltage. This is 33. If I'm not mistaken, that's 33 J33A. This looks like a 33 volt Zener diode. So you'd have 33 volts here. That'll be minus 0.7. Lower than that, 32, or yeah, 31, okay. So that means that the ground has got to be this guy, because that's higher than ground. So this should go to ground. Where does this guy go to? That point goes to there, and it goes to there, and it goes to there, and it goes to, okay, it goes to the FL winding, secondary of the transformer. It doesn't tell us what the voltage is there. So that comes out here, goes there, and it's the top end. Okay, and the diode's facing in. So what we've got here is, this must be ground, where, yep, that goes to ground. And the reason that goes to ground, that's one side of the AC. This side here is half-wave rectified, because you've only got one diode, and it's negative because it's facing inwards. In other words, you rectify the negative half cycle, so this point will be more negative than that point. So that's 0, that's minus whatever. So that's rectified and filtered through that capacitor there. Minus 35 volts over here. Minus 35, okay. And then you've just got the pass transistor, and you've got yourself rectified, and regulated minus 31 volts, which is VPP. So I'm going to look for this voltage, and I'm really hoping that my bet pays off, because all the other voltages, 5 volts goes to the switching, which seems to be working. All the other voltages seem to be there because the unit's working. The unit's working just fine. It's just the display, and it seems that this is the only voltage. This AC and VPP are the voltages that affect the display, and seemingly very little else. So I'm going to go measure this. Where will I measure this? The easiest way to measure this will be on the actual supply board, and it is the last one, the last pin 9 on that connector. But I think I've got access to it, so that's what I'm going to do. Measure these voltages, or at least this one. And the AC, why is the AC connected to there? Oh, okay. Yeah, this is what happens. This AC, let's follow these two lines back to that AC secondary, and I'm not sure what voltage that is. There's a X filter cap on there and a Y filter cap on here. So this is for noise. And then it comes out as AC, no ground reference yet. It goes up here, it's floating, and that AC is floating, and this AC should be floating, but they zap it to minus 16.5 volts using that diode over there, which is a 15 volt diode. So what they're trying to do is they're giving a they're putting all this AC below 0 volts, because it's basically creating an offset of minus 16 volts, and that just helps with the difference in voltage probably between the grid and the heaters, or between the plate and the heaters. You often don't want more than a certain voltage to exist between the plate and the heaters. I know that in tubes you have that. Sometimes you reference it to the either to the grid or actually to the plate voltage, a portion of the plate voltage, so you don't have such a big differential between the heaters and the actual cathode. So yeah, okay, that looks good. So I'm going to check this out, see what we've got, and get back to you. Okay, so to start, I've removed that cable from the main board. That's the one that's supplying 5 volts, 12 volts, 9 volts, AC and the VPP. There's another cable here supplying that top board, the input board I believe, and I've actually unplugged it from that end. So I don't want any voltages going to the boards, I just want to test the power supply. Right, so I'm going to connect the multimeter to ground, which is the second wire. Just checking the screen there, second wire, that's right. I have the amp off because I don't want to create any shorts while connecting these pins on here. And to the first one, I'm switching it on, we should get 5 volts. 5.1, brilliant. Switch it off again. And of course we've got the capacitor holding the voltage. But now I'm going to try ground to pin 3. And that should be, if I touch this, I'm going to get a spark, and I don't want that. That should be 12 volts. 12 volts. Good. Pin 4 is ground as well. Pin 5 is 9 volts. So 4, 5. Switch it on. 9 volts. We've got it. 9 volts. And then pin 6 is P off, and I'm not sure what that does. It's probably an activator, a mute or something like that. Then we've got pin 7 and 8 is AC, and pin 9 is what I'm looking for. So I'm looking for VPP. pin 9, and I want minus 31. Switch it on. Oh, that does not look good. Have I got this on? Ha! Well, let me just make sure I've got everything connected properly. This is too easy. Pin 9. Basically 0 volts. That's my minus 31 volts I'm supposed to have. So, I seem to have got lucky. I'm just checking this again because this thing just sounds a little bit too easy. And I always get a bit suspicious when it works out too well. Alright, I'm going to test, just make sure this thing's on. Test the 9 volts again, or the 5 volts again. That's the top one. 5 volts, yeah. Now I'm going to test the AC. Switch that off. So I don't have 31 volts, or minus 31 volts. I'm going to check pins 7 and 8, and I should have AC. Let me change that to AC volts. And there's pin 8. Let's try that. Pin 7 and 8. Make sure I don't bend any of those pins. And that's 5 volts, 50 hertz. That's my AC. And I now have an indication that the filaments or the heaters work on 5 volts. I'm not sure what it's supposed to be. I don't see any indication anywhere, but this service manual is 71 pages long, so maybe I just haven't seen it. But we don't have our minus 31 volts, which is great news. Because if we don't have our minus 31 volts, I think we can safely assume that we don't have, we found the reason why the display doesn't work. So now I'm going to go a bit further. I want to see if the voltage is coming from the transformer. I'm looking for the winding that says F. In other words, that winding that provides the voltage for the minus 31 volt regulator. Now, I'm just looking here. I think, yeah, it actually shows it on there. It says F, and it's those 2 pins over there. So, once again, that one there. 34 volts AC. That's the one. My supply is coming in. Okay, so I've got my minus 35, or rather, I've got my the coil FL comes through at 33 volts AC, and it meets the diode, and it rectifies it to that capacitor, and then it goes to, at minus 35 volts, it goes to the collector of that transistor, which is Q401. Now, which one is Q401? That's that little guy there. Which one is the collector? Not sure. I have to look at this more carefully. Okay, so that's Q401. And I believe that is the collector over there. So I have this thing on. Just make sure I'm getting nothing there. Yep. So what do I get on there? I'm not getting anything on there. What should I look? Not getting anything on the collector. It is on. That resistor over there is connected to the collector. That's the 2.2K. And I should be getting minus 35 volts there, so it's not even coming in there. It comes in through resistor 401. Where's resistor 401? That's that one over there. I'm getting minus 16 on there. What about the other side? That's the problem, getting to the other side. Well, the other side is actually let me measure this side of the diode. minus 16. That's not good. I should be getting minus 35. I'm getting minus 16 over here, which is where the diode, that's where the diode and the resistor meet. I think what I'm getting there is actually, I think I'm getting the result of that one diode, that 16 volt or 15 volt diode. So I'm not actually getting anything on there. So either the diode is open or the resistor is open. My guess would be the diode. Let me try that. Let me switch everything off. I think our diode is buggered. So let's try that. Okay, try and get the diode. It's a bitch to get it in there. Really tough. There to there. Oh, the diode seems to be fine. Let's try reverse. Oh, the diode's fine. Can only be the resistor then. Let me try that. The resistor. Would that be as simple as that? Is it connected properly? Ha! The resistor's open. The resistor is open. Now what is that? That's R401. R401 is 47 ohms, and it looks like, oh man, it looks like a quarter-watt resistor, and it is open. Now isn't that nice? I wonder, that resistor would open if too much current came through. Why would too much current come through? Well, if we had a short on this transistor here, if that shorted, that would go to, that would do it, yeah, transistor shorted. Or, there's one other explanation which might be the case, which probably explains it a little bit better, and that is if this capacitor started leaking too much. And if this capacitor leaks too much, it increases the current flowing through the diode and the resistor, and that resistor would open from excessive heat. So that would imply that this capacitor could be the cause of that fault. These things usually happen in tandem. You don't get a resistor failing just because it wants to. There's usually something else wrong with it. Now, I'm going to connect a resistor in here in parallel with this, because that's open anyway, and I'm going to see what happens to the voltage. Let me set that up. So here I've got a 47 ohm resistor, and I've just connected it to these leads, and I've connected those leads across that resistor over there. So what I'm going to do now is set up the voltmeter again to see if I get that minus 30 volts or minus 31 volts, and that should tell us whether it's just the resistor or whether the, well, it could be the transistor that's gone as well. So we'll just have to wait and see. Okay, I have the meter now measuring between ground and the supposed minus 31 volts, and I'm going to switch it on. Haha, I love it. I love it. It's not minus 31, but it's minus 30.5. I have restriction on the dim bulb tester, but it's drawing 40 milliamps, so that's not really having any effect. If I do bypass it, okay, minus 30.6. Now that would make sense to be slightly lower if the capacitor is indeed drawing more current than it should. In other words, if it's leaking more than it should. So I think we found the problem. I think what we had here is the capacitor probably started leaking, caused an excess current draw. That excessive current draw bypassed or increased beyond the, or created a power loss or power drop across that resistor, which was in excess of its maximum. And we had the resistor fail. Yep. All right. I'm happy. I'm really happy. And I want to thank 12-volt vids for the clue, because you don't get to this quickly by yourself unless you've done it before, or, as in my case, seen somebody else do it. And it's this is actually the result of following a hunch which happened to work, which is why you're seeing the video. If this had not worked, I don't know if I'd put the video up, because I would really have looked stupid, which isn't difficult sometimes. Anyway, I'm going to do the following now. I'm now going to remove the power supply board, which now seems, or makes it a lot easier to get it out, because it's just one board. I think there are about 4 screws on the bottom there, and I think it'll actually fit through the bottom or through the side. And what I'm going to do is replace that resistor, probably replace the diode as well, because it might have been overstressed. Check the Zenas. It's easy enough to check them with the board out. I've got my Zena tester. And then I'm also going to have a look at all the capacitors, because if that one capacitor has leaked, and we'll check that when I take this out, I'm not sure how well the others are doing. So I'm going to take this opportunity to basically renew some of the capacitors on this board and try and ensure this thing works for a hell of a lot more years. Okay, I'm getting on with it. Okay, here we are. The board is back in place. I removed it. It was quite easy to remove. What wasn't easy to do was to film with 2 cameras, like I tried to do earlier on in the video. So I lost a lot of footage again. But then never mind, that was just removing some caps and putting some caps in and testing ESRs and all that sort of jazz. Nothing too exciting. And I found nothing too exciting either. I replaced the resistor that was open. I replaced the diode, even though it looked okay, but I think that diode had been a little stressed. It was looking a little grotty. Then those 2 capacitors in that power supply itself, in the display supply, in the minus 31 volt supply, regulator supply, were actually a bit high on ESR, especially the first one, which is probably what caused the resistor to open. So that was replaced. The others, I replaced a couple of them. I checked them all, and most of them seem to be fine. Now, let's switch it on. Why not? Watch this. Ta-da! Beauty. It's looking good. And of course the problem was never the playing, it was just the display, and it's as bright as it was when this thing came out of the factory, and it's working like a charm. Now, I'm not going to play this through amps because that's not the objective here. Also, I don't want to get copyright strike, but if you, well, you can hear it's there. Just through the phones. The timer's working. You can forward this, you can stop it, pause it, you can do whatever you like with this thing. It's as good as new. And it's actually a hell of a piece of equipment. Not that we have too many DATs these days. It's sort of a format that's gone out, but hey, cassette decks are coming back. And who knows, maybe this will be a fad in the future, because this thing's certainly going to be around for a long, long time. Anyway, thanks for watching. I hope you enjoyed this. I certainly did. It really is a pleasure working on this top quality gear. It really is satisfying to put this thing back where it belongs, which is in use for many, many years. And if you liked it, please click like, share, subscribe, and all that jazz. And if you want to support the channel, you can do so by going to Patreon. The link's at the end of the video. All right, thanks for watching. Bye for now.